Hello everyone, welcome back to the class of Theory of Earth Pressure. So during previous lectures, we have gone through the basic theory regarding earth pressure and earth pressure at rest. Now we are going to study what are the other two pressures, that is active earth pressure and passive earth pressure. So let us see two diagrams consecutively here. So what are this diagram suggest? How the active and passive earth pressure develops. Normally, the magnitude of the lateral earth pressure depends upon the movement of the retaining wall relative to the backfill and upon the nature of the soil. This figure shows the variation of the lateral earth pressure with movement of the retaining wall. And the next figure shows the variation of coefficient of earth pressures, that is Ka and Kp with the horizontal strain. So the center point indicates the earth pressure at rest. When the wall moves away from the backfill, mobilization of the internal resistance of the soil takes place, which builds up in directions away from the wall, and hence the earth pressure on the wall decreases. This decrease of earth pressure continues until the full resistance has been mobilized. The earth pressure does not decrease beyond this point with further movement of the wall. This minimum pressure is called the active earth pressure, that is indicated as Pa. If on the other hand the wall moves towards the backfill, the earth pressure increases because the shearing resistance built up in directions towards the wall. The pressure reaches to a maximum point when the shearing resistance of the soil has been fully mobilized. So any further movement of the wall does not decrease the pressure. So this maximum pressure is known as passive earth pressure and it is indicated by Pp, and the center between the active earth pressure and the passive earth pressure is known as earth pressure at rest, which we already have studied previously. So this is the pressure intensity diagram, and similarly this is the coefficient of active earth pressure and at rest and the passive earth pressure. So what is the basic theory behind the active earth pressure? The active earth pressure theory indicates that when the wall moves away from the soil, here in this case the predominating force is the vertical pressure, that is gamma into z. So when there is no initial lateral movement, so the value of the earth pressure will be k0 into gamma into z. But as the wall moves away from the backfill, sigma v value will remain same, but the value of sigma h will decrease. That means it indicates the active state. And what will be the passive state? Exactly its opposite. That means when the wall moves towards the field, then the value of the lateral pressure, that is sigma h, will increase and sigma v will remain constant. Hence this state is known as passive earth pressure state. So to clearly understand this, so let us focus in another diagram. So how do these theories are being developed? The theory on which the computation of the stress in plastic equilibrium is established is based on the theory of plasticity. The theory of plasticity pertaining to the soil is mainly based on the Moore theory of rupture. So mainly when a body is said to be in a state of plastic equilibrium, if every point of it is on the verge of failure. Rankine investigated the stress conditions corresponding to those states of plastic equilibrium, which can be developed simultaneously throughout a semi-infinite mass of soil. So the equation of equilibrium in 2 dimensions are automatically satisfied by the Moore circle. And the state of plastic equilibrium can be represented by two straight lines at an angle phi to the sigma axis. Thus, the Mohr circle is convenient tool for studying the stress conditions at equilibrium both before and at the yield of the soil. Here the figure shows the active and the passive state of plastic equilibrium in a non-cohesive soil with the horizontal ground surface. So in active case, the major principal stress sigma 1 is vertical and the minor principal stress sigma 3 is horizontal, as we have discussed previously. So here we can see two circles, and the circle 1 represent such a state in which the pole P2, here the pole is indicated by P2, corresponds to the minor principal stress, while the point P1 corresponds to the major principal stress. The circle touches the failure envelope at C1 and C1 dash, and hence P2C1 and P2C1 dash shows the direction of failure planes or slip lines. These slip lines have also been shown in the next figure. So similarly, for the passive state, the minor principal stress is in the vertical direction while the major principal stress is in the horizontal direction. Hence circle 2 corresponds to the passive state, in which the pole P3 corresponds to the major principal stress. The circle touches the failure envelope at C2 and C2 dash, and hence P3C2 and P3C2 dash are the directions of slip lines corresponding to the passive case. And this ratio of the horizontal stress and the vertical stress is known as the coefficient of earth pressure. So when the soil is in the active state of plastic equilibrium, then sigma h is equals to sigma 3, and then what happens? The ratio of sigma 1 by sigma 3 equals to tan squared 45 degree plus 5 by 2, which gives the value of passive earth pressure. And when the ratio of sigma h by sigma v equals to Ka, that gives 1 by tan squared 45 degree plus 5 by 2, that is the coefficient of active earth pressure. So in this way, coefficient of passive earth pressure and coefficient of active earth pressure are being determined. So let us move on to some of the cases where active and passive earth pressure can be found out. So the first case will be the backfill will be horizontal and the soil will be cohesionless. So this is the first case where a retaining wall is present and the backfill soil is horizontal. So let us consider a small element at a depth set below the ground surface. So when the wall is at the point of moving outwards, the active state of passive equilibrium is established. Hence, the value of horizontal pressure will be minimum than the vertical pressure. Hence, it will be a state of active earth pressure. Hence, the active earth pressure intensity acting on the wall is being given by the integration of the pressure from the total height, that is from limit h equals to 0 to h equals to capital H, and by integrating the value we can get the value of half of Ka gamma into h square, where Ka is the coefficient of active earth pressure, which is given by 1 minus sin phi by 1 plus sin phi. So this case, if we consider for the passive earth pressure case, what happens then? In this case, if the same element is considered at a depth z below the ground level, then the backfill of the wall moves towards the backfill, and this case we will find out the coefficient of passive earth pressure, which is given by 1 plus sin phi by 1 minus sin phi. Hence the total pressure acting on the wall can be given by the equation P suffix P, that is total intensity of passive earth pressure, is equal to integration of 0 to h Pz and Tz, where Pz is given by Kp into gamma into h, and by integrating we are giving the value half of Kp into gamma into h square. So this is the formula for passive earth pressure when the backfill is horizontal, and this is the formula for active earth pressure when the backfill is horizontal. So these are the two cases for backfill being horizontal. So hence from this we can conclude that the relationship between Kp and Ka is inversely proportional to each other, that is Kp equals to 1 by Ka. So next let's go to another case where the soil is in the submerged condition. So in this case what happened, the sand fill behind the retaining wall is mainly saturated with water. So the lateral pressure is made up of generally two components: lateral pressure due to the submerged weight of the soil and lateral pressure due to the water at a distance z from the surface. So hence the intensity of the pressure, active earth pressure, is given by Pa into Pw, where Pa is given by Ka into gamma dash into Z plus Pw is given by gamma W into Z. And if Z equals to capital H, then this pressure is given by gamma B into H into Ka plus gamma W into H. This is the total active earth pressure acting at the bottom of a retaining wall in case of submerged soil. And if there is a need for finding out the total earth pressure intensity, which is mainly on the total falling on the total retaining wall surface, then it can be formed by integrating both these values from 0 to h. That is what we did in the previous case. So by integrating we can get the value as half of Ka into gamma into h square along with your gamma W into h square. So this is the value for submerged soil, Rankine earth pressure for submerged soil. And if this soil is partially submerged along with a surcharge. So what is actually surcharge? Surcharge is an extra load which falls on the retaining wall, on the top of the retaining wall. This is known as surcharge. So after falling the surcharge, and if the soil is in the partially saturated state, then what happens? So this is the case. For partially saturated clay, one depth of the soil is approximately moist and the other part will be submerged. Hence, two type of bulk density or two type of saturated densities are obtained in this case. And as there is a surcharge and which is uniform, this uniform intensity of surcharge is known as Q, which act at a equal or uniform increment until the total height of the retaining wall is achieved. So the lateral pressure in this cases may be formed for the uniform surcharge. It will be K into Q. For the earth pressure active case, in case of some partially submerged soil, it will be gamma into H1 plus gamma B into H2 into Ka, where gamma and gamma B are respectively our moist unit weight and the submerged unit weight of the soil or the backfill, and along with that the unit weight of water multiplied by the height of the retaining wall up to which the water is being retained. So by summation of these three terms we will get the active earth pressure value in this case. So another case is present, which is Rankine active earth pressure for a sloping cohesionless backfill. So for sloping cohesionless backfill, one assumption is already present that the backfill is not necessarily has to be horizontal. The sloping surface may be inclined, and this inclination angle with the horizontal is known as beta. So if beta is the inclination angle of the slope, hence we can obtain the value of the slope and active earth pressure coefficient by plotting a Mohr circle. So how can we achieve this Mohr circle? This figure shows that the Mohr circle, which corresponds to the principal stress intensities of sigma 1 and sigma 3. So the Mohr circle is the locus of the point that represents the resultant stress intensity at all planes passing through the point under the consideration. Hence we can find the resultant stress intensity sigma and P, which are known as also conjugate stresses onto conjugate plane. So the obliquity of the sigma and the P is angle beta. So from there we can get the value of active earth pressure coefficient as cos beta multiplied by cos beta minus root over of cos square beta minus cos square phi divided by cos beta plus root over of cos square beta minus cos square phi, and hence the earth pressure coefficient PA is given by gamma z into cos beta minus of root over of cos square beta minus cos square phi divided by cos beta plus root over of cos square beta minus cos square phi. So from there we can find the value of the coefficient of active earth pressure, and this resultant pressure always acts at h by 3 above the base of the wall. So for the passive earth pressure, as we already know, the relationship between the active and the passive state is that they are reciprocal to each other. So hence for the passive case the value will be just inverted of the previous one, that is cos beta equals to cos beta plus root over of cos square beta minus cos square phi divided by cos beta minus root over of cos square beta minus cos square phi. So this is the case for the passive earth pressure for sloping cohesionless backfill. So now let us consider for the cohesive soil. So all these cases as we have studied, so one assumption remained constant for all these cases, that the soil must be cohesionless. So all the cases we have studied previously are mainly used for the cohesionless soil. So where fraction or the friction coefficient phi is predominating. So for the cohesive soil, how the theory is being provided? For the cohesive soil, in this figure we can easily see the variation of lateral pressure along the height of the retaining wall. It can be seen that if cohesion is 0, then the pressure at the base would have been equal to a value gamma h into cos square phi. But as there is a certain amount of pressure which acting in a negative direction, and because of this negative pressure, a tension crack is usually developed in the soil near the top of the wall up to a depth of Z0. Also, the total net pressure upon the depth to Z0 is 0. That means that a cohesive soil should be able to stand with a vertical face up to a depth of 2 into Z0 without any lateral support. The critical height of this an unsupported vertical cut is given by HC equals to 4C by gamma into tan alpha. So from this figure we can easily say that for cohesive soil there is a development of tension. So here what is the height up to which the tension prevails? That is, the height is Z0, and double of this height is known as the unsupported height of the vertical cut. In the case of very soft clay or very cohesive soil, the value of phi in this case is provided as 0. So these are the theories of active and passive earth pressure for both cohesive and cohesionless soils.